In this video, what I want to do is solve the differential equation x double dot plus 10x dot plus 21x is equal to 0 with the initial conditions x of 0 is equal to 4 and x dot of 0 is equal to minus 3. And I want to solve it using a Laplace transform. So the first thing we need to do when we're solving a problem using Laplace transforms is actually take the Laplace transform and convert this equation to the S domain. Now, in order to do this, we're going to need a few properties. The first is with this the second derivative. So for the second derivative, we can use what we have in this table of properties of Laplace transforms for the second derivative. And here we'll have this is s squared x of s minus s of x of 0, so our initial condition, minus whatever our x dot of 0 of this initial condition is. So this initial condition is this initial condition is right here. We'll plug that in just a few minutes. Okay, so this is this x dot term. This all comes from this x double dot term. Now we have this plus 10x dot. So we're going to have to multiply whatever we have from table 2, which is the first derivative, by 10. So we're going to have, this is equal to 10 s x of s minus 10 times x of 0. So let's write it like this. And again, this is just my initial condition. Okay, and then finally we have plus the 21x. So we're going to have plus 21. X becomes x, so x of s is equal to 0. Now what we want to do is we want to bring all of our terms together, and we want to solve for this big x of s. So we're going to have s squared plus 10s plus 21 x of s, and that's this term, and this term. We bring them together and we factor out the x of s. Next, let's put in our initial conditions. So this is going to be minus 4s, that's this term right here, with our initial condition x of 0 is equal to 4. Now we're going to have minus a minus 3, so plus 3, that's this initial condition. And then finally, we're going to have a minus 10 times 4, so minus 40 is equal to 0. We're solving for x of s, so these three terms are going to combine and go to the other side of the equation. So we'll have s squared plus 10s plus 21 times x of s is equal to 4s plus 3 minus 40. So this is going to be plus 37. Finally, to finish this, we're going to divide by this s squared plus 10s plus 21. So this is going to be equal to 4s plus 37 divided by s squared plus 10s plus 21. All right, so we've solved for x of s. The next thing we need to do is solve for constant. We're going to have to break this up a little bit further and solve for constants that we need. So to break this up further, this denominator jumps out at me. I need to solve for the roots of the denominator. And this one is actually easy because I can break this up as this is 4s plus 37 divided by s plus 3 and s plus 7. So it's very easy to factor that polynomial. Now, this becomes really the equation I want to look at. I want to use partial fraction expansion, and I want to say, all right, so a over s plus 3 plus b over s plus 7. The goal right now is to get my denominators to be all the same for all of these parts of the equation, and then I can equate my numerator. So to do that, this is going to be a over a times s plus 7 plus b times s plus 3 divided by s plus 3 times s plus 7. So now at this point, I'm going to stop writing my denominator. This denominator right here is the same as this denominator right here. So they're equal. And what I'm going to have is this algebraic expression of the numerators. I'm going to have this as 4s plus 37 is equal to as plus 7a plus bs plus 3b. Now, I want to combine like terms over here, so I'm going to say this is equal to a plus b times s. I took this term and factored out in s. And then all I have left is 7a plus 3b. Now my next step is to equate my s terms and my non-s terms. So my s terms are going to form the equation 4 is equal to a plus b. My non-s terms are going to form the equation 37 is equal to 7a plus 3b. Now this is an easier equation, I think, to solve for. So I can say a is equal to 4 minus b. I can substitute that into the second equation. So I have 37 is equal to 7 times 4 minus b plus 3b. So 37 is equal to 28 minus 7b plus 3b. I get 9 is equal to minus 4b, and b is going to be equal to minus 4 over 9, or minus 9 over 4. Okay, I'm going to substitute that back right here, and I'm going to have a is going to be equal to, well, this is going to be 16 over 4 plus, the minus signs are going to combine, plus 9 over 4. So a is going to be equal to 25 over 4. So now what I'm going to do is I'm going to take this equation right here, and I'm going to say, all right, so a is 25 over 4 times 1 over s plus 3. And then b is minus 9 over 4. Let's do it like this. Plus a minus 9 over 4 times a 1 over s plus 7. And this is this x of s. Okay? Now, the last thing I need to do, so I've solved for my constants. I have an equation. The last thing I need to do is bring this back into the time domain. So how do I do that? Well, I look at this equation right here. I have two terms, and if I look at my table of Laplace transforms, one of them that sticks out to me is 1 over s plus a is going to be equal to e to the minus at. Now I can use this relationship, or this table entry, for both of these entries right here, and just keep the coefficient. So my function x of t is going to be equal to 25 over 4 times, well, this is e to the minus 3t, and then minus 9 over 4 times e to the minus 7t. And I get this again by keeping this coefficient, so that coefficient stays, and using this table entry right here to figure out that this turns into e to the minus 3 over t, this turns into e to the minus 7 over t. So this becomes my answer. X of t is equal to 25 over 4 e to the minus 3 minus 9 over 4 e to the minus 7t. So hopefully this has given you an introduction to how to solve a differential equation using a Laplace transform.